We're going to shift now to the question of what does it cost to add cybersecurity into software development projects. We talked a lot about the technology and the process, but of course most executives are going to say, yeah, but what's it going to cost me? So this is work being done by Dr. Barry Boehm and his doctoral student Elaine Venson at the University of California, Southern California, in the Center for Systems and Software Engineering. Most of you know Barry Boehm. He's one of the fathers of the field of software engineering. In fact, you've seen a couple of slides today that showed the ISO 25000 product quality model. The first such model was developed by Barry and his colleagues at TRW back in the 1970s. And it was really an improvement on all the models that have been developed since. But Barry has had a long history of working in various areas. The COCOMO model is used widely, especially in the Department of Defense. And so now he and Elaine Venson are working on what does it cost to add cybersecurity into software development projects. So Barry and Elaine, I'll turn it over to you.
I think Elaine might still be, you're unmuted. You might need to unmute on your side, because we can see your screen but can't hear you just yet. It's still muted, looks like. Try again. Can you try unmuting? Looks like we're having an issue. 1 second.
Hi, Tracy, can you hear me?
Yes, we can hear you.
Okay,
Great.
Dr. Boehm will talk here.
Okay, thanks, Elaine. Good afternoon, everybody. Basically, it's a pleasure for us to be part of this activity. We're enjoying a number of stimulating collaborative work activities with CISC and CAST in terms of things like tool sharing. We have a life cycle technical debt analyzer that is very scalable. It's been able to analyze the technical debt of 1.5 billion lines of code over 15 years and things like that. We are also the co-lead of the DoD System Engineering Research Center and have done things like collaborate with MITRE on developing the DoD's System of System Engineering Handbook, and collaborating with the Software Engineering Institute on something called causal cost modeling. The main thing that we're going to do, and Elaine will talk about, is evolving the constructive cost model, or COCOMO. One of the things that we're finding is that the original COCOMO basically talked about size in terms of lines of code, and now with things like web services, it's a totally different ballgame. So we're trying to evolve COCOMO in those directions. We also have an activity going on with a small company called Parallel Agile, which basically is able to take model view controller architectures and take 50 students and give each one of them a use case and develop a significant pieces of software. So there's a recent book on parallel agile that you might be interested in. But for now, we'll pass it on to Elaine and talk about what she's doing with secure software development costs.
So thank you, Dr. Boehm. Let's move to the next slide. Okay, so I'll start talking about secure software development costs, how we analyze the aspects of these costs. Then I will present the scale we developed to measure the level of secure software development. Next, I will show the cost estimates that we got from security experts for each level of the scale. And finally, I will talk a little bit about the next steps in our research. So in the beginning of the years 2000, initiatives for secure software development and security practices started to appear in response to the software vulnerabilities. So in this slide, we have some examples like the Microsoft Secure Development Lifecycle, the OWASP Software Assurance Maturity Model, and the obscene touch points. But despite these many initiatives, still today, many development teams and many organizations still don't apply these practices. And they often point out the costs as the main reason for not adopting these practices. So in secure software development, security will compete for a slice in a limited budget. So to add more security, organizations and development teams usually need to remove features from the scope. So in one side, less investment in security often means higher fixing costs, patching, downtime if the application is attacked, recovery costs, and reputation loss. But as benefits, priority can be given to features or having a better time to market. On the other side, more investment in security implies spending effort and costs on security experts, security tools, security training, improving the processes, and it requires these investments to be done in the early phases of software development. But we have benefits. The vulnerabilities are prevented and detected during the software development. We avoid risks, and we can reduce the total cost because after delivery, we will have less costs with patching and fixing bugs and vulnerabilities. But the decision on doing more or less security has to do with the risks and security goals of each application. So how to know the right amount of effort to put into security? Security investment models have been studied on the field of information security for some time. And in this chart, we see a production function of security costs and benefits decomposed by the security level. So to increase the security level, we increase the costs, and the cost depends on the security productivity. So how the teams can effectively apply the practices or not. And as we raise the security level, we get the benefits here in this curve. But at some point here, no matter how much is invested, the benefits will be lower than the costs, because the benefits diminish over as we invest more on the costs. So Costs, benefits, and the security level are base metrics for developing these investment models and to provide information for the decision makers. So in software engineering, we still know very little about these metrics. So initially, we are focusing on the cost of security according to the security level. And we are going to discuss these two aspects here. So the goal of secure software development is to build in security to preserve the assets. And from this goal, we can derive requirements, both functional and non-functional. So when we talk about functional requirements for security, we are talking about implementing security features or security controls and security components. And how can we measure these elements? So we can do this through sizing metrics like lines of code, function points, objective points, or other metrics. On the non-functional side, non-functional security requirements are usually constraints over the security features, controls, and other features, application features. So these constraints can be expressed and verified through security practices. For example, threat modeling, security requirements, penetration testing, etc. So, but how can we measure the level of application of these practices? So this is something that we are working on. So taking those two elements, so for the security feature size, we can directly measure them using sizing methods. But if the team or the organization doesn't have expertise to do this sizing estimation, we can use historic data to determine a security sizing factor to help estimators. On the level of application of the security practices, we developed a ordinary scale based on the application of such practices that we call the secure software development scale. So to develop this scale, we used the literature as base, the literature maturity models like the BSIM, OWASP SUM, and the COCOMO descriptor of attribute levels. So this scale, the secure software development scale, excuse me, defines degrees of application of the security practices. So we started with these 13 most common practices that were consolidated in a study by Morrison. So we have applied security requirements, applied data classification scheme, applied threat modeling, document technical stack, which is something similar to the software bill of materials that were discussed earlier, apply secure coding standards during the development, apply security tooling like static analysis, dynamic analysis, perform security testing based on the requirements and threat models, perform penetration testing, perform security review of the deliverables, publish operations guides so that administrators and users know how to correctly configure the software, because we have many vulnerabilities that are exploited due to wrong configuration. Track vulnerabilities, so during development, so they can be prioritized and solved during development. Improve software development process to incorporate the lessons learned over the process, and perform security training. So we use these 13 practices, and we for each one of these practices, we described how they would be executed in increasing levels of rigor and coverage. Then we grouped these practices in 3 categories: security requirements and design, security coding and tools, and security verification and validation. And then next, we summarize the practices in each group so we could have a summarized version for the users to easily select the correct level of secure software development. So this is the latest version of the rating scale. It has been refined with the participation of the estimation experts and also security experts. For each one of the 3 groups, we have specific descriptions on how security practice would be executed. So as a way to test the scale and gather initial estimates for the security levels, we conducted an online Delphi study with security experts. So this picture illustrates the online Delphi process. So the facilitator sends an estimation request to the participants. The experts analyze the information, in our case, the levels of secure software development, and submit their estimates back to the facilitator. So the facilitator compiles these estimations, analyze the assumptions that the participants did, and send back the summarized results to experts so they can know and compare their estimates with the other participants, and also see the assumptions that need to be made in these estimates. And with this information, they can review and submit their estimates. And this can happen many times as needed. And in the end, a report with the results is produced. So we conducted an online Delphi last month, and we invited people from the software security group on LinkedIn. It's an international group that gathers these security experts. And we had 2 rounds. So in the first round, we have 17 participants, and in the second round, we received responses from 14 participants. And they said they had an average of about 11 years of experience with secure software development, and also about 11 years of experience with software estimation. So these 3 histograms present the distribution of the responses for each of the 3 groups of security practices. So the productivity range is the ratio between the highest level and the lowest level of the scale. So for example, a productivity range of 2 means that to apply the practices at level 4, it would take twice more effort compared to level 0. So we can see that the results are very right skewed, as most of the answers are concentrated between 1 and 2 for the 3 groups. Here we have the summary results for each group. So we can see that the coefficient of variation is high even for the second round. So there was no much strong consensus among experts on the added security effort. And based on the median, the overall productivity range was 3.675. Using this productivity range and an exponential growth equations, we can obtain the effort multipliers for each level of the scale. So we did this one based on the median. We also asked the participants to estimate the increase in the application size. So how much more function points, requirements, lines of code would be necessary to develop the security features for each level. So this question was sent only in the second round of the Delphi. There was a good level of agreement for level 1. For example, we had an average of 17% increase in software size due to the implementation of security features. But as we increase the level, the agreement tends to get a little bit worse. So how are we going to use these estimates? So the estimates from experts, from this information, we will calculate the means and variance as we showed. And we're also going to get information from projects. We'll calculate the security parameters and other model parameters with multiple linear regression. And then we can combine these two sources of information, applying Bayesian analysis, to produce an optimal combination of these two sources. So we propose adding this a new security parameter in the COCOMO equation form. So the COCOMO 2 equation calculates the effort in person months, having as input a constant A, the size of the application, an exponent E representing economies or diseconomies of scale, and N effort multipliers for various projects, products, and personnel attributes. So we propose the addition of the security parameter SECU as an effort multiplier corresponding to the level of secure software development required by the application being estimated. And also on the size component, it will include the security functional features that can be directly estimated or can be estimated using a security sizing factor. So for doing this, producing this model, to build this model, we are collecting data from security experts, estimation experts. So we are inviting people to participate. So we did this first Delphi session with security experts, and we are planning a new session to further evaluate that estimates with other estimation experts. We are also inviting companies and organizations to contribute with project data for the model calibration. And we are also planning to use open source software data. So we can use APIs to collect data from public repositories, and we will complement that data with surveying this software developers, open source software developers. So if you're interested in this research, please get involved. You can leave your name in the poll that Trace will make available. You can also contact me or Brad Clark, which is the project coordinator for COCOMO 3. And we'll be starting a new round of the Delphi study in the next week. So it will be good to have your participation. So
I just displayed the poll here. Hopefully everybody can see that. Mm-hmm. Great. Okay, so we'll leave this open for a little bit and then close it out.
Okay, I don't see any questions in the question queue. But if anybody has any questions, raise your hand and Tracy can unmute you.
Could I ask, can you hear me? This is Joe Jarzenbeck.
Yes, Joe.
The question I have is related to the fact that a lot of times people look at security features as an additive thing, as opposed to looking at secure software. And I'm wondering how you make a distinction within the study. Because as the example, when we talked about earlier on data protection, the common weakness enumeration talks about flaws in software. They could be security related, but they're not necessarily a security function, but more of a non-functional attribute of the software. It's a flaw. How do you deal with that in the study?
Yeah, so these are the two aspects that we try to analyze here. So when we discuss security, software security, so often some people talk about security functional requirements, like the controls we see in the common criteria, for example, when we build components for authentication, when we build cryptography, auditing. So these controls that are implemented by the developers, they increase the software size. But
right.
On the other hand, we have all these security practices that are non-functional, like doing the security reviews, penetration testing, threat modeling. So all these practices, they don't increase the size of the software, but they need to be they need to be conducted to try to prevent and detect vulnerabilities both in the security controls and security features and in the application features. So they are conducted across all the software, the whole software. They need to cover the whole software. So we see this way. So this is why we have in the cost model, we try to treat these two aspects of the cost related to security, software
and
security.
So you're able to account for all the rework that is done when they don't actually mitigate those weaknesses up front. It's rework either in reused components, or is that one of the ways that you're able to look at costing here? Because cost of rework is often not attributable to software cost, as an example, especially in comparing one development over another.
So not exactly. So here we try to treat the cost of building security features. So for example, if the application needs to have a module for auditing all the actions that the users are doing in the software, this needs to be implemented in code. So this we treat as the functional aspect. But for all the effort that, for example, people need to inspect the code or inspect other artifacts of the project, so this is the non-functional component. So this is the effort for the team to conduct these tasks, to execute these practices, all these practices that are not dependent on the security features. They need to be done despite the number of security features or controls that are implemented.
Right, but that gets into what CISC is doing with our technical debt measures. It's like, this is stuff that if you don't get rid of it early on, it's just a matter of when, and the cost of eliminating that goes up. And so I'm assuming you've looked at that as well.
Yeah, so the idea of this is to have the information on the actual cost of doing this early on, so during the development, and to prevent these vulnerabilities to appear during operation. So we expect that the total cost, if we consider the development plus the operation, the idea is that the total cost will be reduced because we are taking care of these vulnerabilities early on in the life cycle.
Okay, Elaine, thank you, and Barry, thank you very much for this interesting session on trying to figure out what the cost is of adding cybersecurity into software development projects. We're going to take a 15-minute break now, so come back at the half hour, and Luke McCormick will lead us into a session on continuous diagnostics and mitigation with Kevin Cox. So see you in 15 minutes.